Welcome back. Now we're going to begin talking about vectors. What is a vector? So some of the quantities when we talk about measurements are measured using only their magnitude, such as time, which could be measured in seconds or minutes or hours, but one unit. Length, which could be measured in feet. Mass, which could be measured in grams or pounds. But how do we measure topics such as displacement or velocity or force? In all of these cases, we need to describe both a magnitude, a size, and a direction. And when we have to have a magnitude and a direction, this is a situation where we use a vector. So what are some examples of displacement and velocity and force? So for example, with displacement, we could say an object moves a certain distance in a certain direction. So for example, a hiker follows a trail 5 miles, that's a magnitude, to the west. That gives us a direction. Or velocity. An object travels a certain speed in a specific direction. I realized that was typed incorrectly there, so I went ahead and rewrote that. As in, a wind blows 15 miles per hour from the northwest. 15 miles per hour is the speed, that's the magnitude, and then from the northwest, that is my direction. And then we have a force. A force could be a push or a pull, but again, exerted on an object in a specific direction. So here specifically, we could say a 200-pound force is required to pull that cart in the direction up the 30-degree incline. So the main thing we want to understand when we talk about these vectors is a vector in the plane is a directed line segment, whereas the length of a vector represents magnitude, and it has an origin and a terminal, an initial and a terminal point. So length represents magnitude, and then the direction in which this vector is pointing makes that an actual vector. So it has a length and a direction. So I could say here, combined with direction. So two vectors are equivalent if they have the same magnitude and direction. That's the main thing we want to understand about vectors. Okay, so a vector has magnitude and direction, and if we want to say they are equal or equivalent, they must have the same magnitude and direction. So for example, if we let 1 centimeter, this little length here, imagine this is 1 centimeter, and let 1 centimeter represent 5 kilometers per hour. If we wanted to draw a vector to represent 15 kilometers per hour from the northwest, that vector would be coming from the northwest toward the origin. Northwest is going to be at that 45-degree angle. And if this 1 centimeter represents 5 kilometers, then in order to represent 15 kilometers, we would need this to be 3 centimeters long. So essentially there's 1, 2, 3 straight out of the northwest. So we'll imagine that measures exactly 3 centimeters long, and we would draw that vector, the 3 centimeter long vector that looks like this. And this is how we could represent a wind of 15 kilometers per hour out of the northwest. Okay, so magnitude and direction. So as we've just stated, two vectors are equivalent if they have the same magnitude and direction. So I'm going to talk about two different ways that we can note these vectors. One way would be to write AB, and then I have a directed line segment above it. That means I have a vector that starts at A and ends, it has this terminal point here at B. So we start at A and we go to B. We have an initial and a terminal point. And really, you could rather just say, we'll draw it like this. We'll say A, B. Now, another way that we represent vectors is you'll see in your text they use a boldface lowercase letter. So we can use that bold letter without the vector notation above it. And so if I said AB equals this bold-faced letter V, that would mean V would have to look exactly the same at the angle and length. Now, in this class, when I write that, I'll probably still use my vector notation above it to indicate I'm talking about a vector. But these two vectors, AB or little v, they have the same length, essentially, and then the same direction. So they've got that same angle, maybe off the horizontal. When we talk about length or magnitude, really, we're just using the distance formula, which is a variation of the Pythagorean theorem. And as we talk about magnitude, we're going to use bars. So absolute value means the distance from 0. So in this situation, we'll say the magnitude of V, magnitude of vector V, is the square root of the x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So since we know this vector magnitude formula, we are given a picture here with 3 vectors on it, and we're asked to show that U is equal to OR. Well, in order for us to do that, we must show that they have the same magnitude and direction. So if we look at the vector for U, the magnitude would be the distance formula. So the magnitude of U is going to equal the square root of 2 minus negative 1 squared plus 4 minus 3 squared. That gives me 3 squared plus 1 squared, which is 9 plus 1, or the square root of 10. So I'll just simplify that there, square root of 10. What is the magnitude of OR? So the magnitude of the vector OR, we'd calculate that the same way by subtracting our x's and y's, squaring, and then summing. So we would have 0 minus negative 3 for my x's squared plus 0 minus negative 1, running out of space, squared, but 3 squared plus 1 squared is 10. So we have the square root of 10. And we can see that both of our vectors have the same magnitude. But again, that is not enough to show that these two vectors are equal or equivalent because we must have the same magnitude and direction. Well, these vectors are both lines, so we can find the slope for each. So the slope for vector U would be the change in y, 4 minus 3, over the change in x, 2 minus negative 1, which is 1/3. And the slope for vector OR would be 0 minus negative 1 over 0 minus negative 3, which again we get is 1/3. So because both have the same magnitude and both have the same direction or slope, we can say that these two vectors are equivalent. So in this video, just to refresh, we talked about what a vector is. A vector has magnitude and direction. So when you draw a vector, it has a specific length and a specific direction indicated by an arrow. We can find the magnitude, basically just using the distance formula for the length of that vector. And then also we can show that two vectors are equal if they have the same magnitude and direction. As always, email me if you have any comments, questions, concerns. If you just want to talk, I'm here. I want to help you be successful. So, see you in a couple seconds in the next video.